Hello and good morning everyone. Welcome you all to India's largest e-learning platform Unacademy, and I welcome you all to my session Antennas MCQ series, and welcome to all to Gate Conqueror channel. We are into very important series here, Antennas MCQ series, and this session is a marathon session. Will be very much useful for you people, where comprehensively I will try to cover what we had covered in this particular complete series of EMFT. So mark my word here, this is going to be very, very important. So everyone please confirm the video and audio once before we move further. Just confirm the video and audio once, dear. Yeah, please confirm. A very important session, dear. Try to concentrate. We are into the Antennas MCQ series. This is part 13 of MCQ. As I told you, in this session I'll try to revise all the concepts of EMFT that we had covered previously as a main concept. Then of course we'll also try to do some more MCQs in antennas, which will be useful for all the competitive exams where antennas is the syllabi. Before we start, let me introduce myself. I am GC Reddy. I have 15 plus years of experience in teaching, guiding and mentoring GATE and ESC aspirants. I work as motivational speaker pan-India from the past 12 years, an expert in field theory and communications. This is the official link for Telegram channel. You can join us on Telegram so that you'll get the complete support of all the faculty members of the Gate Conqueror channel. As I told you, we are into Antennas MCQ series, which is part of EMFT, and as you know, we are growing in numbers as a team. The Gate Conqueror team is growing, and we are determined to complete the syllabi for GATE 2023 comprehensively. So that's our target here. This Gate Conqueror channel must be one-stop solution for all of you who are preparing for a competitive exam and who are preparing for GATE and ESC 2023. This channel must be a one-stop solution for all of you. So we are trying to take a lot of pain in completing this GATE 2023 comprehensively for the benefit of students. So I'll also explain my part in this of completing EMFT. This antennas is also part of EMFT, as you know. I'm determined to complete EMFT comprehensively in this particular series. I want to complete EMFT comprehensively. As you know, EMFT contains 5 modules. Module 1, elements of EMF theory. Module 1, elements of EMF theory. Module 2, EM wave propagation. Module 3, transmission lines. Module 3 is transmission lines. Yes dear, what's the doubt? Module 4 Waveguides, Module 5 Antennas and Optical Fiber Communication. This Module 1 Elements of EMF Theory is complete syllabus for EEE, and for EC it is one module out of the 5 modules. So we have vast syllabi. We have vast syllabi for EC people and less syllabus for EEE people. For EEE people, this is a complete syllabus, and this I had created a playlist on the Gate Conqueror channel for this module with 40 videos and 50 hours of content. See here, generally, according to my knowledge, maximum number of hours they teach on any YouTube channel for elements of EMF theory will not be greater than 10 hours. 10 is the maximum. Against that, here in this playlist, we got 50 hours of content only on elements of EMF theory with great emphasis on basics. Then we also have a playlist for EM wave propagation. In EM wave propagation also completely new approach, systematic scientific approach we can say, with lot of some concepts, lot of good concepts which will increase your understanding about a wave in depth. So the complete approach, you can say a new approach altogether of teaching EM wave propagation. We also created a playlist here with 10 videos and 20 hours of lecture. There is also some wonderful playlist here. This is not yet done. We need to complete some numerics on pointing theorem, and we also need to complete wave polarization and also reflection and diffraction of plane waves. Like I can say 70% is done, 30% is left out. We'll definitely go through these this particular module also in this particular week. Then transmission lines and waveguides we need to start. We're not started. And antennas I covered under Antennas Mahamarathon series. So instead of keeping a complete subject in a given playlist, I divided this into modules and had created the playlist so that we can develop this playlist also for the benefit of students. So antennas I covered under Antennas Mahamarathon series. This playlist is also a very unique playlist here because we had covered 18 videos here with 38 hours of content like never before, because antennas maximum content is 8 or 9 hours. That is what they teach on any YouTube channel. Against that, we got 18 videos and 38 hours of content for Antennas Mahamarathon series. In this session, I'll comprehensively explain the most important concepts that we had covered in all this series. So in that way, this session is going to be very important here. So ask everyone to join the session very soon, and if you try to interact with me, then we'll share more knowledge. So already on this Gate Conqueror channel, we have 3 playlists. For module 1, we have 50 hours of content. For module 2, we have 20 hours of content. For module 3, we have 38 hours of content. So in this way, I can say already we have 108 hours of content on EMFT, and I'm ready to take 112 more hours of content, making this as 220 hours content exclusively for EMFT, and all the aspirants who are preparing for GATE and engineering services can prepare through our channel, where EMFT is a main syllabi. for EMFT syllabus, wherever EMFT syllabus is there, students can prepare comprehensively without any doubt using our particular channel, Gate Conqueror. Any doubts there, you can ask. Any doubts? Any doubts you can ask dear. Anyone, any doubts you can please ask. So let me explain in detail about module 1. Module 1 is about elements of EMF theory, which is common for both electrical and ECE. For electrical it is complete syllabus, and for ECE it is only just module 1. And the style of my teaching is like whatever I teach in a way such that it will be useful for GATE and engineering services and all other competitive exams. I don't specifically teach so that you can grasp only GATE or only engineering services, but you can grasp or you can use this for both GATE and engineering services as well as all other competitive exams. So what we had covered, the main concepts, I just focus on the main concepts what we had covered in elements of EMF theory, and why this playlist is special when compared to other playlists on other channel. This playlist contains 40 videos with total of 50 hours of content. As I told you, maximum 10 hours content will be available on any other channel. Against that, here we have 50 hours of content. Now you might be wondering what it makes like 50 hours of content. Why 50 hours of content and what we had covered in this 50 hours of content? Let me discuss on that very clearly. In this, actually, why EMFT is difficult? If I ask this question, why EMFT is difficult? Why students feel that EMFT is a difficult subject? Basically, students feel that EMFT is difficult because they lag in basics. If you are having some strong basics, as you know, EMFT subject requires some very good basics, or basics related to vector calculus, basics related to coordinate systems, and also they should be perfect in the shortcuts and all. So this was my primary idea, that we need to make students comfortable with these basics. So I included some 15 hours out of 50 hours. 15 hours of content I included only for basics. Now that makes this particular series very unique, because we had included basics 15 hours. Only complete 15 hours is only dedicated for basics. What we had covered under basics is we had covered elements of vector calculus, we had covered coordinate system, important concepts I'll try to explain here, listen carefully. Under elements of vector calculus, And the first concept, elements of vector calculus. We started with the basic quantity called scalar. Just here. Can anyone tell me what is scalar? A scalar is something which has only magnitude but no direction. Such quantity is called as scalar quantity. Examples, time, distance, speed, all these are scalar quantities, including voltage and current. Now, this is, I explained in this, the module very clearly. So many of you, actually like 90% of the people, generally think that current is vector quantity because it is having magnitude and direction, but which is not true. Current is not a vector quantity. Current is actually a scalar quantity, but most of us feel that current is a vector quantity, but it is not. Why it is not, I'll try to explain here also very shortly, and for in detail explanation you can go through the module 1, elements of EMF theory playlist of 40 videos where it will be very clear for you. So scalar is generally represented by capital letters and given you examples. Next, we defined vector. A vector is one which is having both magnitude and direction. A vector is one which is having both magnitude and direction given by bar on it. It has both magnitude and direction. Examples, velocity, acceleration, displacement. All these are examples for velocity for the vector quantity. And if you are taking some electrical quantities, if you try to consider some technical electrical quantities, current density is a vector quantity. Okay, so force, torque, and all these are vector quantities which are having both magnitude and direction. Third one, we have discussed about unit vector. Unit vector always gives you the direction of vector represented in this way. A suffix capital A suffix capital B, A suffix capital C are nothing but directions of vector A, vector B, vector C. Similarly, if I write AX, AY, AZ, these are unit vectors along XYZ direction. These are unit vectors along XYZ direction. Okay. Now, when we have started with addition of vectors, just like you add numbers, we cannot add vectors. Therefore, we need some rules to add vectors, under which we have discussed about parallelogram law and triangular law. Triangular law is also called as head to tail rule. Again, for in detailed explanation about parallelogram law and head to tail rule or triangular law with some good examples and all, please go through the module 1 playlist. As I told you in this class, only I try to revise what we had covered in our subject. On Gate Conqueror channel, exclusively we have discussed about EMFT concepts. What concepts we have discussed, I will try to discuss in this particular class. Please inform all of your friends that this Gate Conqueror is a one-stop solution if you want to comprehensively prepare for EMFT. Then we had seen about basic laws of vectors. Basic laws of vectors. What are basic laws of vectors, dear? Commutative law. We had seen commutative law of addition and multiplication. Similarly, associative law of addition and multiplication. distributive law and distributive law. What are these laws? Let me explain. Commutative law of addition. If A and B are two vectors, A plus B is equal to B plus A. This is called commutative law of addition and multiplication. If K is a scalar and A is a vector, then K into A is equal to A into K. This is commutative law of multiplication. Associative law. If A, B, C are three vectors, A plus of B plus C is equal to A plus B plus C. This is associative law of addition. Similarly, if K and L are two scalars, A is a vector, K into L into A is equal to K into LA. Associative law of multiplication. This is distributive law. K into A plus B is equal to KA plus KB, where K is scalar, A and B are vectors. Can anyone tell me what is distributive law of multiplication? Chakravarti, good morning. Can anyone tell me what is distributive law of multiplication? Anyone? Yeah, please tell me what is distributive law of multiplication. Very simple, no? But this is a regularly asked question. This is a regularly asked question in your interviews. What is distributive law of multiplication? Yes, dear, anyone? Distributive law of multiplication. Distributive law of multiplication does not exist, because already distributive property is used here, but many 99% of the students 99% of the students do not know about this distributive law of multiplication. Does not exist. So these kind of hard basics you need to understand very clearly if you want to excel in EMF. Okay, next. Then we went for multiplication of vectors under multiplication of vectors. We went for dot product, scalar product, cross product, or vector product. What are these, dear? One second. 1 second here. Okay. Dot product is also called as scalar product. What is dot product here? If A and B are two vectors, A dot B is equal to mod A mod B cos of theta AB, where theta AB is a small angle between A and B. This is the formula that is used when angle is given. Second case, it is given as A is AX plus AY plus AZ B is BXAX plus BYAY plus BZAZ A dot B is equal to AX BX plus AY BY plus AZ BZ. That's A dot B. This is when angle is not given. Yeah, hello JK. This is when angle is given and this is when angle is not given. Now, my basic question is, this dot product obeys how many basic laws? Can you tell me that this dot product obeys how many basic laws? It obeys how many basic laws? Dot product obeys how many basic laws? Okay, tell me, does it obey commutative? Does it obey commutative? If dot product must obey commutative law, A dot B must be equal to B dot A. A dot B must be equal to B dot A. Yes, of course, A dot B and B dot A both are same. You'll get the same answer. A dot B is equal to B dot A. Therefore, dot product obeys commutative. Okay. Anyone, can it obey associative? Does dot product obey associative? Yes, Prakash. Does it obey associative? If it needs to obey associative, A dot B dot C must be equal to A dot B dot C. A dot B dot C. It does not, okay, it does not obey, good morning Srikanth, it does not obey associative, very good. What is the reason why it does not obey? Because B is a vector, C is a vector, dot product of two vectors is a scalar quantity. Once you get a scalar quantity here, you cannot do a dot product between a vector and a scalar. Therefore, writing itself is not possible. It's an absurd. Therefore, dot product does not obey associative law. Next is distributive. Does it obey distributive law here? Does it obey distributive law? A dot of B plus C is equal to A dot B plus A dot C. Yes, it obeys distributive law. Please verify by yourself. Everyone, please verify whether these are obeyed or not. Take some examples and verify whether these are obeying or not. So dot product obeys commutative, does not obey associative, and obeys distributive law. If you go for a cross product in multiplication, cross product, A is a vector, B is a vector, and A cross B is equal to mod A mod B sin theta AB. Theta AB is the small angle between A and B into AN. This is the magnitude of the cross product, because cross product of any two vectors is one more vector which must have magnitude and direction. And this is the direction. This is magnitude and this is direction. Okay. This is when angle is given. If angle is not given, define A is equal to AX plus AY plus AZ, and B is BX plus BY plus BZ. A cross B is determined by using determinant. Determinant, first you write the unit vectors of both the vectors, then the first vector coefficients, which are AX, AY, AZ, then the second vector coefficients BX, BY and BZ. BX, BY and BZ. This is A cross B. This is when angle is given and this is when angle is not given. Now you tell me, cross product obeys, cross product or vector product obeys how many basic laws? Yes, anyone? Yeah, session name is not wrong, Amit. This is a comprehensive series. Yes, it's a comprehensive series where we are trying to cover basically followers who are following the Gate Conqueror channel. They should know the amount of content that is available on our channel. That is the attempt here. So don't worry about that, okay? Don't give much stress on that. Fine. So cross product, does it obey commutative or not? Okay, you had asked the question at a good time. Let us do some revision, okay? Please complete transmission line theory. Yes, I told you, dear, yesterday also I told you, we will complete transmission line theory. You give me time up to April ending, okay? You give me time up to April end, I'll complete EMFT 220 hours. Don't worry. Is that okay? Transmission line theory 100% will complete. Don't worry. So does it obey commutative? Commutative. Yes, Amit. Does cross product obey commutative law? Is A cross B is equal to B cross A? No, very good. It does not obey. A cross B is not equal to B cross A. It does not obey commutative law. Then what it is? A cross B is equal to minus B cross A. It is anti-commutative. It is anti-commutative. Okay. Yes, correct, very good. But Amit, is this correct or is this correct? Which is correct, Amit? Think and tell me which is correct. Which is correct, Amit? No. Out of those two, which is correct? First one. First one. Okay. Okay, Amit. Give me 5 minutes of time, okay? A is a vector, just 3ax plus 4ay. B is a vector, just 2ax plus 2ay. Okay, Amit. Tell me, Amit, how much is A cross B? Determinant, coefficients of first vector 3, 4. Second vector 2, 2. Resultant AZ. This is 6 minus 8 minus 2 AZ. So let us do B cross A. Determinant B, coefficients 2, 2, 3, 4. Resultant AZ. 8 minus 6, 2 AZ. Minus of B cross A is minus 2 AZ. That means what? A cross B is equal to minus of B cross A. This is correct. Tell me, Amit, which is correct? First statement is correct or second statement? Good. That's wonderful. You should not say first one, okay? It is both. It's both. Why both? Why both? Amit, why both? If you do know minus B cross A, minus B is minus 2, cross A, 3, 4 of AZ, minus 8 plus 6 minus 2 AZ is also equal to minus B cross A. Why? Okay, why? No, Amit. You are not mistyped. It is correct actually. Now you see, listen, lot of concept is there, Amit, here. A cross B is equal to minus B cross A also. That means both first is correct, Second is correct. Both are correct. Both are correct. Both are correct. But I am asking why? Why both are correct? Okay, minus B cross A correct. Minus of B cross A is also correct, no? What is the property it is using there? First one is also correct, no? Direction both same. A cross B and minus B cross A both same, Amit. Both same, both same. Minus B cross A answer. Minus 2AZ. Minus of B cross A answer. Minus 2AZ. A cross B answer. Minus 2AZ. Direction is not getting opposed. Direction is not getting opposed. Both are correct. How? No. Distributive is different. This is, listen, these both are correct. Property of determinant. If a scalar is multiplied to one of the vector in a cross product, you can take it common. That k value here is minus 1. That k value is minus 1 here. Now you got it, Amit? Property of determinant. A cross KB is also equal to K into A cross B. If the scalar is multiplied to both, you take 2 times common. Yes. Got it now? Good, 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 good. So it is not commutative, it is anti-commutative. Next. Is it associative, Amit? Is it associative? Associative means A cross of B cross C. Must be equivalent to A cross B cross C. Is it associative? Is that equal? Is that equal? Most of them think that it is equal, but it is not. Please verify. It is not associative. It is not associative. Distributive. A cross of B plus C is equal to A cross B plus A cross C. Yes, it is distributive. It is distributive. That's about cross product, dot product and cross product and basic laws. Then under elements of vector calculus, we discussed about del and its properties. And as I told you, del is a very, very important operator. Del is a very, very important operator dear, because this plays a very important role in all the Maxwell equations. So we are discussed on we discussed on this del operator also. In-depth discussion was done in the series. Del given by reverse of delta is given as dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az. It is a special operator. Del is a special operator. It's a vector in itself. Del is called as vector differential operator, or it is called as spatial derivative operator. It is called as vector differential operator because it is a vector in itself, and what it is doing is differentiation. Therefore, it is called vector differential operator or spatial derivative operator. It is doing derivative with respect to space coordinates x, y, z. It's a spatial derivative operator. How to use del? When del operated on a vector using the dot product, what it is called here? What this is called? Called as divergence of A. Del is a vector, A is a vector, dot product of two vectors is scalar. Divergence of any vector is scalar quantity. Next. Del operated over a vector using the cross product. This is read as curl of A, orientation of A. Del is a vector, A is a vector, curl of A is a vector. Del operated directly on a scalar is read as gradient of scalar, which is again a vector quantity. When this divergence is 0, A is said to be divergenceless. Vector A is said to be divergenceless vector. Or solenoidal vector. If this divergence is positive, A is source. Now again, in detail explanation with enough number of examples. In detail explanation with enough number of examples I had given. In the module 1 series, dear, please go to the playlist. If del dot A is negative, A is sink. A is sink. Similarly, coming to this curl. Curl of a given vector is 0. Its rotation will become 0. A is said to be irrotational vector. Curl is not equal to 0. It is said to be rotational vector. It is said to be rotational vector. Del of V is called gradient of scalar. Gradient of any scalar is a vector quantity. Is that clear? In this way, we have discussed about del and its properties. Then we have discussed on vector identities. Vector identities are those principles which are followed by all the vectors. First vector identity, divergence of, that means del dot, divergence of curl of del cross. Divergence of curl of any vector is 0. Second, curl of gradient of any scalar is 0. Third, del dot AV. A is a vector, V is a scalar. Del dot AV is A dot del V, V into del dot A. Del cross AV is del V cross A, V into del cross A. Fifth one, vector triple product. A cross of B cross C is B into A dot C minus C into A dot B. These are vector entities we have discussed. This is what we have discussed under elements of vector calculus. Only I am trying to give you the overview. In detailed explanation we are given some, like this thing took me around 7 to 8 hours. You can just imagine. This thing took me around 7 to 8 hours. I explained in 30-40 minutes. So if you go through the series, if you go through the playlist, then you'll understand in detailed explanation of this. That completes first part of the basics. Elements of vector calculus. Second part. Discussed on coordinate systems. In coordinate systems, discussed about types of coordinate system, Cartesian coordinate system, cylindrical coordinate system, spherical coordinate system. And spherical coordinate system. In Cartesian coordinate system, the coordinates were x, y, z. Cylindrical coordinate system, coordinates are rho, phi, z. Spherical coordinate system, coordinates are r, theta, phi. In Cartesian coordinate system, coordinates x, y, z, x limit minus infinity to plus infinity, y limit minus infinity to plus infinity, z limit minus infinity to plus infinity. In cylindrical coordinate system, now if you go for definitions, can even define x, y, z? X is nothing but the shortest distance on x-axis, shortest distance parallel to x-axis, or perpendicular distance from yz plane. Y is shortest distance on y-axis or parallel to y-axis, or shortest distance from xz plane. Z is shortest distance on z-axis or parallel to z-axis, or shortest distance from xy plane. Range minus infinity to plus infinity. Cylindrical coordinate system, rho, phi, z. Rho, radius of cylinder. Rho is the radius of the cylinder. Radius cannot be negative, therefore 0 to infinity. Phi is azimuthal angle made from z-axis to rho, and rho is defined in the xy plane. 0 to 2 pi. Now anyone tell me what is the limit of z and how z is defined? Z in cylindrical coordinate system. Cylindrical coordinate system is also called as circular coordinate system. Cartesian coordinate system is also called as rectangular coordinate system. What is z in cylindrical coordinate system, anyone, and what is the limit? What is z in cylindrical coordinate system and what is the limit? Z is the height of the cylinder. It is minus infinity to plus infinity. Remember, range once defined in any given coordinate system, if the same coordinate is used in another coordinate system, the range will be same. The definition may differ. In Cartesian coordinate system, Z is shortest distance from xy plane, distance on z-axis, or distance parallel to z-axis. Whereas in cylindrical coordinate system, Z is the height of the cylinder. The definitions may vary, but the range will not vary. Range will be same. Spherical coordinate system, R is the radius of the sphere, theta is the co-altitude angle, phi is azimuthal angle. R is 0 to infinity, radius of the sphere. Theta is co-altitude angle or the cone angle, the maximum angle of pi. Phi is azimuthal angle, 0 to 2 pi. Now if you want some in detailed explanation about why the ranges are in this way, I recommend you to go through the playlist where in detail explanation where it was given about these ranges, definitions and all very, very clearly. Please go through the playlist here. Next is point transformation. Point transformation. How to transfer a point, how to convert a point from one coordinate system to another coordinate system. So let me have some discussion, very important topic. Point transformation. Okay, under point transformation, we can convert a point from one coordinate system to another coordinate system. Like you can convert a point from Cartesian to cylindrical. 1 second. Cartesian to cylindrical and cylindrical to Cartesian. Can you tell me how? Cartesian to cylindrical, cylindrical to Cartesian. Okay. Cartesian coordinate system you need to write down like this. Cylindrical coordinate system. Coordinates you must write like this. Z no change, Z is equal to Z. Cartesian to cylindrical. I should write rho and phi in terms of x and y now. Z axis. Y-axis, X-axis, X-axis, Y-axis and Z-axis. This is x, this is y, this is z. Is origin, the distance on x-axis, which is x, distance on y-axis, which is y. If we take a point P here, this is rho. This is rho. This is length parallel to x-axis, which is x. Length parallel to y-axis, which is y. Of course, this is rho. Okay, fine. Now this is from x-axis to rho. This is phi. If you want rho, this is opposite side. This is adjacent side. This is hypotenuse. Hypotenuse is equal to side square plus side square. It's under root of x square plus y square. Phi is tan inverse of y by x, because tan phi is y by x, or phi is tan inverse of y by x. This is how you convert from Cartesian to cylindrical. If you want to convert from cylindrical to Cartesian, then apply sin phi, which is opposite side by hypotenuse, y by rho. Y is rho sin phi. Apply cos phi. Apply cos phi. Cos phi is adjacent side by hypotenuse, x by rho. X is rho cos phi. X is rho cos phi. Okay. X is rho cos phi. Now this is how you can convert Cartesian to cylindrical and cylindrical to Cartesian. Similarly, can convert Cartesian to spherical and spherical to Cartesian. Cartesian to spherical. X, Y, Z are given. I want r theta phi. This is origin and this is r. This is r. This theta here. And this is rho. If this is rho, this parallel line is also rho. This is rho, this parallel line is also rho. This is Z. Then again, this is falling here at 90 degrees. This is hypotenuse. Hypotenuse square is side square plus side square. Hypotenuse under root of rho square x square plus y square plus z square. Theta is tan inverse of rho by z. Rho is under root of x square plus y square by z. Y is same, tan inverse of y by x. And x and y almost were converted here. Only thing is you should write this rho in spherical coordinate system. In spherical coordinate system, if you take sin theta, it is rho by r. Rho is r sin theta. Rho is r sin theta. R sin theta. Sorry. So rho is r sin theta. X is rho cos phi. R sin theta cos phi. Y is rho sin phi. Rho is r sin theta sin phi. Z, if you take cos theta is Z by R, Z is R cos theta. This is how you can do point transformation. This is how you can do point transformation. Okay. Is that clear? So we discussed about point transformation, unit vector relations, and also we went for differential length, differential surface, and differential volume representation in all the coordinate systems, and we had went for divergence, curl, gradient, and a Laplacian in all the different coordinate system, which had completed the second part, that is coordinate system. Thereby we covered this 15 hours of basics there. What we have done in DL, DS, dV is differential length. If you take in Cartesian coordinate system, it is dx plus dy plus dz. The same differential length in cylindrical coordinate system is d rho a rho. This is the value of dl in all the three coordinate system. Differential surface in Cartesian coordinate system, dx dy az, or in simple if you write, we can start with dy dz ax, dz dx ay, dx dy az. This is in Cartesian coordinate system. dy dz ax plus dz dx ay plus dx dy az. The same thing in cylindrical coordinate system. Rho d phi dz a rho plus dz d rho a phi plus d rho d phi az. In spherical coordinates and ds in spherical coordinate system, r square sin theta d theta d phi ar plus r dr sin theta d phi a theta r dr d theta a phi. dv in Cartesian coordinate system, dv dx dy dz, it is rho d phi dz r square sin theta dr d theta d phi, r square sin theta dr d theta d phi. This is dl, ds, dv in all the three coordinate system, as it will become very difficult for us to remember all the three coordinate system different values, which is summing up to 9 formulas. What we do is we take the scaling factors, h1, h2, h3 coordinate system, and parameters u, v, w. If you take Cartesian coordinate system, coordinates x, y, z, scaling factors 1, 1, 1. Cylindrical coordinate system, coordinates rho, phi, z, scaling factors 1, rho, 1. Spherical coordinate system, coordinates r, theta, phi, scaling factors 1, r sin theta. Now we can write dl is equal to h1 du au plus h2 dv av plus h3 dw aw. Similarly, you can write ds h2 h3 dv dw au plus h1 h3 du dw av plus h1 h2 du dv aw, and dv as h1 h2 h3 du dv dw. This is shortcut here. Now we got dl, ds and dv. Instead of 9 formulas, we got them in 3 formulas. Got it? Instead of 9 formulas, now we got it in 3 formulas. Similarly, as dl, ds, dv we have discussed, you can also write divergence of given vector, divergence, curl and gradient, also with single formulas. 1 by h1, h2, h3 dou by dou u of h2, h3, h3 au dou by dou v of h1, h3 av plus dou by dou w of h1, h2 aw. That is divergence, curl of a and del cross a is given by 1 by h1, h2, h3 det of h1 au, h2 av, h3 aw dou by dou u, dou by dou v and dou by dou w. Coefficients h1 au, h2 av, h3 aw. That's curl of area. If I write del value, only del is 1 by h1 dou by dou u of au, 1 by h2 dou by dou v of av plus 1 by h3 dou by dou w of aw. If you take gradient here, gradient of a scalar, we take k, then just add k here. This is gradient of a scalar. If you take Laplacian del square of k, which is del dot del k, this is del dot, no, del of k is a vector quantity. That vector is given like this: 1 by h1 dou k by dou u of au plus 1 by h2 dou k by dou v of av plus 1 by h3 dou k by dou w of aw. Okay, so now del dot of this, it should be written, a is replaced by this. Okay, so how do you write this? Is 1 by h1 h2 h3 dou by dou u of, now this can be written as dou by dou u of del dot a is asking. Okay, so del dot a is asking, del v we have written, this del dot of this we need to do. So a is now here replaced by this function. So dou by dou u of h2 h3 au should be replaced by 1 by h1 dou k by dou u dou k by dou u plus dou by dou v h1 h3 by h2 dou k by dou v dou by dou w h1 h3 h1 h2 by h3 or dou k by dou w. This is Laplacian. So now what we have done here is we have decreased the derivation, the number of formulas from 9 to 3. Here previously used to have 3 formulas, now only 1. Here 3, only 1. Here 3, only 1. Similarly for divergence, curl and gradient also we are given only 1 formula. These concepts are very, very important. We are almost like we spend around 15 hours of content here, 15 hours of time here for addressing all these basic concepts, which is the uniqueness of this particular module. So we have discussed this. With this we completed the basics. Then we started elements of EMF theory. Elements of EMF theory. We divided this into 2 parts. Static field theory and time varying field theory. Static field theory and time varying field theory. In static field theory, we discussed on electrostatics and magnetostatics. In electrostatics, we discussed about 2 important laws. One is Coulomb's law, generalized law that governs electrostatics, and we had seen their applications on point charge, line charge, surface charge and volume charge. And a special law called Gauss Law, which can be applied over Gaussian surfaces. And also we had seen applications for point, line, surface and volume charges. In magnetostatics, we had seen the general law like Biot-Savart law and its application over line current, and we had seen the generalized law, Ampere's law, which can be applied over Amperian surfaces. Gauss law is also special law which can be applied. Gauss law is a special law that can be applied over Gaussian surface, and Ampere's law is a special law that can be applied over Amperian paths. Ampere's law and application, and we had seen applications for line current, surface current and volume current. And in this process, we have derived Maxwell equations for static fields. We have derived Maxwell equations for static fields. Maxwell equations for static fields are: first equation, closed surface integral of d dot ds is equal to volume integral of rho v dv, integral form, differential form del dot d is equal to rho v. Source Gauss law. Source Gauss law. Hello Ankit. Yes dear, tell me. Ankit. Yes dear, tell me. That's Gauss law, electrostatic fields. Second one, we derived closed integral of E dot dl is equal to 0. Differential form del cross E is equal to 0. Source conservative property of electrostatic field. Third one, closed loop integral of H dot dl is equal to surface integral of J dot ds del cross H is equal to J. This is from Ampere's law. Fourth one, closed surface integral of B dot ds is equal to 0. Differential form del dot B is equal to 0. This is from Gauss law for magnetic fields. Let us see what we have done one by one. Gauss law. According to the statement of Gauss law, the amount of flux that is cut by any closed surface is equal to the charge enclosed by the surface. This is called Gauss law in true form. This is called Gauss law in true form. From this, if we take electric flux density, it is electric flux per unit surface area. If we consider a small surface area ds, flux associated with it is ds, and this is electric flux coulomb and area meter square, coulomb per meter square. If we consider this, then d psi e is equal to d into ds scalar notation. In vector notation, d psi e is equal to d dot ds. From this, psi e is equal to surface integral of d dot ds. Psi e is equal to surface integral of d dot ds. Surface integral of d dot ds is equal to charge enclosed. Charge enclosed. How is charge enclosed given? Q is equal to line integral of rho L dl, surface integral of rho s ds, volume integral of rho v dv. Generalized form, this is equal to volume integral of rho v dv. This is called the integral form of Maxwell first equation. Integral form of Maxwell first equation. And if you take this LHS, closed surface integral of d dot ds is equal to, from divergence theorem, it is volume integral of del dot d dv. This is from divergence theorem. Again, in-depth understanding of divergence theorem. How you got this, I explained in the playlist. Please go through the playlist. This is substituting volume integral of del dot d dv is equal to volume integral of rho v dv, implies del dot d is equal to rho v. This is called the differential form. Differential form or point form of Maxwell first equation. Point form of Maxwell first equation. We have derived this. Next, from conservative property of electric field. Again, dear, I am not going in depth of this. Just I am trying to revise the concept. That's it. For in detail explanation, you can please go through the playlist. Conservative property of electric field. Relation between V and E. V is equal to minus integral of E dot dl. When you close the loop, the potential will become zero. How it is? For example, if you take these 2 points A and B, if you want to calculate potential difference between these 2 points VAB, it is VA minus VB. Minus integral moving from B to A, E dot dl. That is how it is related. So V is equal to minus integral of E dot dl. Now, if you extend this up to C, you get VAC, VA minus VC. If you extend it up to D, VAD, VA minus VD. If you close this, VA minus VA, 0. Therefore, when you close the loop, the value of potential is becoming 0. It implies closed loop integral of E dot dl is equal to 0. This is called integral form of Maxwell second equation. Now, if you apply Stokes theorem on this, according to Stokes theorem, closed loop integral of A dot dl is equal to surface integral of del cross A dot ds. Now, if you apply Stokes theorem on this, surface integral of del cross E dot ds is equal to 0. Implies del cross E is equal to 0. It's called differential form. Differential form of Maxwell's second equation. Similarly, if you go for Ampere's law, according to Ampere's law, the circulation of magnetic field intensity is equal to current enclosed, where current density J is equal to current per unit surface area. If you take a small surface area, ds, current associated with it is di, unit is ampere per meter square. From this, di is equal to J into ds, scalar notation. Vector notation, di is equal to J dot ds, current density vector, surface area vector. I is equal to surface integral of J dot ds. This is when the current is enclosed by open surface. I is equal to closed surface integral of J dot ds. This is when the current is enclosed by the closed surface. Now writing here, closed loop integral of H dot dl is equal to. Now shall we take open surface or closed surface? Because this is loop here, loop will enclose only open surface. Surface integral of J dot ds. This is called integral form of Maxwell third equation. Integral form of Maxwell third equation. Integral form of Maxwell third equation. Now, if you apply Stokes on it, the surface integral of del cross H dot ds is equal to surface integral of J dot ds. This implies del cross H is equal to J. Differential form, this is integral form, this is differential form of Maxwell third equation. Then we went for non-existence of magnetic monopole. Non-existence of magnetic monopole. A magnetic monopole does not exist. If you take a permanent magnet, it will have two poles in it, north pole and south pole. Magnetic flux lines will move from north pole to south pole like this. Move from north pole to south pole like this, forming closed loops. So what is the net flux here, dear? Anyone? What is the net flux here? What is the net flux here? What is the net flux here? Net flux is 0. We know psi m is equal to closed surface integral of B dot ds. Implies closed surface integral of B dot ds is equal to 0. This is integral form of Maxwell fourth equation. Integral form of Maxwell fourth equation. Applying divergence on it. This is volume integral of del dot B dV is 0, implies del dot B is equal to 0. Differential form of Maxwell fourth equation. So this is how we have derived all the four Maxwell equations for static fields. And besides this, we derived Poisson's and Laplace equations, and we have done some wonderful videos on this also. Some wonderful numerics we had solved, and in the playlist you can see some wonderful videos regarding the Poisson's and Laplace equation and their applications. Very unique problems we had done on this. Then we had also solved boundary conditions. Solved boundary conditions, and we had seen the formulas and derivations for capacitors and inductors. And also we had modified this equation in time varying fields. We got Maxwell equations for time varying fields. Maxwell equations for time varying fields. Maxwell equations for time varying fields. We kept the first equation and the fourth equation unchanged. The second equation is replaced by Faraday's law, and third equation is replaced by Maxwell contribution. Faraday's law, closed loop integral of E dot dl is not 0 now, but it is equal to surface integral of minus dou b by dou t dot ds. Differential form del cross E is equal to minus dou b by dou t. Source Faraday's law. Next is Maxwell contribution. Closed loop integral of h dot dl is equal to surface integral of j plus jd dot ds. This is del cross h is equal to j plus jd, where j is conduction current density given by sigma e, jd is displacement current density given by dou d by dou t. From this we got Maxwell equations for time varying fields. From this we got Maxwell equations for time varying fields. Let's see what we have done in Faraday's law. According to Faraday's law, the induced EMF within a closed path is equal to rate of change of flux linkage, where flux linkage lambda is equal to n into psi m, where n is number of turns. Later on, scientist Heinrich Friedrich Emil Lenz introduced the negative sign, stating that the induced EMF always opposes the flux produced it. Therefore, we got VEMF is equal to minus n times d psi m by dt. Relation between V and V is equal to closed integral of E dot dl. Because now this is time varying field, this value won't become 0 when you close the loop. And for a straight conductor, n is equal to 1. Therefore, this is equal to minus d psi m by dt. You know, psi m is surface integral of B dot ds. Substituting, closed loop integral of E dot dl is equal to surface integral of minus dou b by dou t dot ds. This is integral form. If you apply Stokes on it, surface integral of del cross E dot ds is equal to surface integral of minus dou b by dou t dot ds. implies del cross E is equal to minus dou B by dou T. Differential form. Before we go for Maxwell contribution, let me explain you conservative property of charge. What is conservative property of charge, dear? According to conservative property of charge, the rate of decrease of charge within a closed volume is equal to net outgoing current. This is minus d by dt of rate of change of decrease of charge. Q in is volume integral of rho v dv is equal to net outgoing current, closure surface integral of j dot ds, because closure surface enclosed volume. This implies closure surface integral of j dot ds is equal to volume integral of minus dou rho v by dou t dot minus dou rho v by dou t of dv. Applying divergence theorem, this is volume integral of del dot j dv is equal to volume integral of minus dou rho v by dou t of dv, implies del dot j is equal to minus dou rho v by dou t. This is from continuity equation, which is natural phenomena and which cannot go wrong. This equation cannot go wrong. Del dot j is equal to minus dou rho v by dou t. Now it is easy for us to explain Maxwell contribution. What is Maxwell contribution? What Maxwell told is, there is some problem in this Ampere's law, del cross H is equal to J. What he had done is he took divergence on both sides. When he took divergence on both sides, he got this. But this is divergence of curl of any vector, this must be 0. Therefore del dot J is equal to 0. But you know from continuity equation, del dot J is equal to minus dou rho v by dou t. This is ambiguity and this cannot be wrong. Therefore there is some mistake with this. What Maxwell has done is he had modified this equation into del cross H is equal to J plus JD, where JD is the displacement current. Actually Maxwell is the one who had coined the term displacement current. Therefore del cross H is equal to J plus JD, taking divergence on both sides, del cross H is equal to del dot J plus JD. Divergence of curl of any vector 0. 0 is equal to del dot J plus del dot JD. According to continuity equation, you know del dot J formula. Del dot JD from this is equal to minus of del dot J. From this, del dot J is minus dou rho v by dou t, minus of minus plus dou rho v by dou t. You know from Gauss law, del dot D is equal to rho v. Substituting, del dot JD is equal to dou by dou t of del dot D. That implies del dot JD is equal to del dot dou D by dou t. Implies JD, displacement current density, is equal to dou D by dou t. Dou D by dou t. JD, displacement current density, is equal to dou D by dou t. Clear? So the new modified equation is del cross H is equal to J plus JD, where J is conduction current density, depends on conductivity of the material, sigma E. JD is displacement current density, depends on displacement or the time varying field, given by dou D by dou t. This is a new equation. In this way we modified this equation, we got Maxwell equations for time varying fields. These two equations are replacing these two equations. We got Maxwell equations for time varying fields. With this, these are the main things we had covered in module 1. And in boundary conditions also we had seen dielectric boundary condition and dielectric conductor boundary condition and dielectric conductor boundary condition. Okay, so that was from module 1. These are the things that we have discussed in module 1. For this we took 40 videos and 50 hours of content to explain these things with all the numerics, previous year question papers, practice questions, in detail explanation we are done on these. Clear? Next, module 2. EM wave propagation. Module 2, EM wave propagation. In EM wave propagation, it's in topics like EM wave propagation in free space. Free space means conductivity is 0, epsilon r is 1 and mu r is 1. 2. EM wave propagation in materials. Sigma not equal to 0, epsilon r greater than 1 and mu r greater than 1. Let's see. EM wave propagation. In EM wave propagation in free space, we derive terms like alpha attenuation constant, beta phase shift constant, V velocity and eta intrinsic impedance. In EM wave propagation in materials, we have discussed the generalized formulas for alpha and beta, and we derived the velocity, generalized value of eta, we derived loss tangent or dissipation factor tan phi sigma by omega epsilon. From that we have derived the classification of materials, and we have seen EM wave propagation in good conductors. In good conductors, we have seen terms like alpha for a good conductor, beta for a good conductor, velocity, penetration depth or skin depth, penetration depth delta, surface resistance Rs, and intrinsic impedance eta. Fourth one we had seen EM wave propagation in good dielectrics. There also were derived expressions for alpha, beta, velocity and eta. We had seen EM wave propagation in perfect dielectrics. EM wave propagation in perfect dielectrics. These 5 topics put together is called as EM wave propagation through different mediums. We had seen pointing theorem. Pointing theorem we had completed, and these two in that particular series or in that particular playlist we need to finish this, okay? Up to here we are finished. We derived P is equal to E cross H. Pointing theorem we derived P is equal to E cross H. Up to here we are done, and these two small topics are left out. That is wave polarization one, and the second one is reflection and refraction of plane waves. Reflection and refraction of plane waves. These two are left out. Just follow that particular series or playlist of EM wave propagation. Already we had finished 10 videos with 20 hours of content. This analysis also is very, very important here. We have done some wonderful analysis on EM wave propagation through different mediums. Please go through that. We'll see what we have done in analysis. What we have done in analysis, we'll see. Exactly what we have done in analysis, we'll see. Fine. One second. Okay, fine. Let us do some analysis of where we try to derive the formulas or analysis of alpha, beta, velocity and eta for different mediums. Now if you go for free space, in free space, what is the value of alpha dear? Value of alpha is 0. When you go for perfect dielectric, let us go for the perfect dielectric. The derivations are already done here. Just I'll do some very good analysis that is required for the same. 1 second. Yeah. For perfect dielectric, there won't be any conductivity. Here also alpha is 0. Let me start with sigma otherwise. For free space, sigma is 0. Perfect dielectrics, the sigma is 0. Good dielectrics, sigma is a small value. Good conductors, sigma is a large value. For perfect conductors, sigma is infinity. So what is happening? Sigma is from 0 to infinity, it is increasing in this way. Similarly, if you take alpha, for free space it is 0. For perfect dielectrics, it is 0. For good dielectrics, alpha is sigma by 2 into under root of mu by epsilon. Of course, sigma is there, very small value, so alpha is also small. And for good conductor, it is alpha is equal to under root of omega mu sigma by 2. Sigma is large value, therefore attenuation is also large. And for perfect conductor, it is infinity. This shows that alpha is increasing. As the conductivity increases, alpha also increases, attenuation increases. It means what? It means what? Waves will get more attenuated in a good conductor when compared to good dielectric. Waves will get more attenuated in good conductor when compared to good dielectric. That's the meaning. Beta, free space, omega into under root of mu naught epsilon naught. Here, epsilon r is greater than 1, mu r is greater than 1. So this is the least possible value for beta. Slowly the beta value increases. Beta is omega into under root of mu epsilon. Slowly the value got increased. In good dielectric, you get beta is equal to omega into under root of mu epsilon. It is further still increasing. 1 plus sigma square by omega square epsilon square. For good conductor, beta is under root of omega mu sigma by 2. Sigma is infinity, therefore beta is also infinity. Next, going to velocity. Velocity is omega by beta. This is 1 by under root of mu naught epsilon naught. This is velocity, c by under root of mu r epsilon r. So velocity, here velocity is equal to velocity of light. Here it is decreasing. Here it is the highest value. Here it is the highest value. Here velocity omega by beta 1 by under root of mu epsilon 1 minus sigma square by omega square epsilon square. Good conductors, velocity is equal to under root of 2 omega by mu sigma. Sigma is very small, large value. Velocity decreases. Here velocity is 0. Here velocity is highest. Slowly it is decreasing to 0. Last one, eta under root of mu naught by epsilon naught 120 pi or 377 ohm. Here it is 377 ohm into under root of mu r by epsilon r. Generally mu r is 1, epsilon r is greater than 1, so eta value is decreasing. So eta value is decreasing. Eta value is decreasing. And here you want the value of eta here. Just we can derivate that. Eta is equal to under root of omega mu sigma one second here. Yeah, eta is under root of generalized expression for eta. Eta is equal to under root of omega mu sigma plus j omega mu. J omega mu eta is equal to j omega mu by sigma plus j omega epsilon. This is good dielectric. Sigma is far less than omega epsilon. Taking j omega epsilon common, eta is equal to this is I am doing for good dielectric, okay? Good dielectric. J omega mu by j omega epsilon into one plus sigma by j omega epsilon. Eta is under root of mu by epsilon into 1 plus nx, 1 plus sigma by 1 minus sigma by 2j omega epsilon. But you know, j square is minus 1, j into j is minus 1, j is minus 1 by j. This implies eta is equal to under root of mu by epsilon 1 plus sigma by 1 plus j times of sigma by 2 omega epsilon. Very clearly, eta is a complex value here. Eta is equal to under root of mu by epsilon into 1 plus j times of sigma by 2 omega epsilon. For a good conductor, if you take eta, sigma is far greater than omega epsilon. Eta is under root of j omega mu by sigma. under root j is equal to 1 plus j by root 2. Eta is 1 plus j by root 2. Root j equivalent is 1 plus j by root 2. 1 plus j times of omega mu by 2 sigma. Eta is under root of omega mu by 2 sigma. Eta is under root of omega mu by 2 sigma plus j times of under root of omega mu by 2 sigma. It is complex in nature. Here eta is 0. We write this in R angle theta form and substitute sigma is infinity, it is 0. So this is the analysis dear that we have done from EM wave propagation, and also we had completed pointing theorem and got instantaneous pointing vector E cross H, complex pointing vector 1 by 2 E cross H conjugate, average pointing vector 1 by 2 real part of E cross H conjugate, reactive pointing vector 1 by 2 imaginary part of E cross H conjugate. This we have done. Problems on this also we'll try to do. When we try to continue EM wave propagation series, we'll try to do some more problems on that. Okay. Module 3, transmission lines we need to cover. I'll start this module very soon. Module 4, waveguides also we need to start. Module 4 is waveguides. These waveguides also we need to start very soon. Module 5, optical fiber communication and antennas. Optical fiber communication, I'll start a separate series. Antennas we had covered. Antennas Mahamarathon series. This comprises 18 videos and 38 hours of lecture. 18 videos and 38 hours of lecture. What we covered in Antennas Mahamarathon series is we started with basic or fundamental quantities. We started with basic terminology of antennas. Then we had seen current distribution in antennas, radiation mechanism of antenna, radiation mechanism of antennas, it's in radiation mechanism of antennas, and we discussed about radiation pattern of antenna. Under radiation pattern we have discussed terms like main lobe, side lobe, nulls, first nulls, beam width between first nulls, half power beam width. We had discussed something like this, and also we had seen some radiation parameters of antennas, in which we had discussed about the main topics like gain or simple gain, directive gain, power gain where losses are considered, directivity, efficiency, radiation resistance, radiation intensity, beam area, power, density. These kind of topics were discussed under radiation parameters of antenna. Once we are comfortable with these radiation parameters of the antenna, we had a discussion on monopole, dipole and loop antennas. Monopole, dipole and loop antennas. After discussion on monopole, dipole and loop antennas, we went for antenna arrays. In antenna arrays, we started with 2-element array and discussed the patterns of all the 5 standard cases. Case 1, distance lambda by 2, alpha 0, giving broadside array. Case 2, distance lambda by 2, alpha pi, giving endfire array. Case 3, distance lambda by 4, alpha minus pi by 2, a heart shape pattern with its major lobe in the first quadrant. Distance lambda by 4, alpha pi by 2, heart shape pattern with main lobe with its main lobe in second and fourth quadrant. Here main lobe in first and here the main lobe in first and fourth quadrant. Here the main lobe in second and third quadrant. Then we are seeing distance d is lambda, alpha is 0, which gives flower pattern, or we have main lobes in all the quadrants. This 2-element array analysis we have done. Then we had extended it into n-element array. N-element arrays. In n-element arrays, we had seen 2 main cases: broadside array and endfire array of an n-element array. And in special arrays, we had seen endfire array with increased directivity, endfire array with increased directivity, which is called Hansen and Woodyard array. Hansen and Woodyard array. And also we had seen special array called binomial arrays. This is to reduce the side lobes. Binomial arrays to reduce side lobes. And here instead of alpha is minus beta d, we maintain alpha is minus beta d minus pi by n. So the directivity can be increased by 78.9%. So the directivity can be increased by 78.9%. It's in binomial arrays. Once this arrays concept is done, we went for the 7 sister antennas. In 7 sister antennas, started with folded dipole antenna, folded dipole antenna, shifted to Yagi-Uda antenna, then we had seen helical antenna, famous for circular polarization. Then we had seen microstrip array antenna, horn antenna, parabolic reflector antenna, and lens antennas. Total 7 antennas were discussed here. These 7 antennas famously are called as 7 sister antennas. Besides these 7 sister antennas, we discussed about resonant and non-resonant antennas. In resonant and non-resonant antennas, under resonant we had seen antennas like monopole, dipole antennas. The non-resonant, mainly we had discussed about V antenna, inverted V antenna, and rhombic antenna. Besides this, we had also seen a very important concept, antenna measurements. Antenna measurements. In antenna measurements, it's in radiation pattern measurement, and also we had seen the 2 methods that are involved in the radiation pattern measurement. Can anyone tell me what are the 2 methods that we discuss in radiation pattern measurement? What are those 2 methods that we discuss in radiation pattern measurement? What are those 2 topics that we discuss under radiation pattern measurement? High frequency method and low frequency method. In high frequency method, we keep both the antennas at stationary position and we try to, this is primary antenna, this is secondary antenna. We keep both the antennas at stationary position and we try to rotate the secondary antenna its own axis. And by using a pattern recorder, we try to note down the pattern of the antenna. Similarly, in low frequency method, primary antenna is kept constant and secondary antenna is rotated in a constant radius around the primary antenna. This is low frequency method. So we had seen this low frequency method, and also we had seen distance requirements. What does distance requirement tells you? The distance should be greater than or equal to 2d square by lambda, where d is largest dimension of the antenna. Then we had seen uniform illumination requirement. Uniform illumination requirement. Then we had seen measurement of gain. Measurement of gain and directivity. Under measurement of gain, it's in primary method, which is first method. It is also called as three antennas method, and also it's in second method, measurement of absolute gain of two identical antennas. Use two identical antennas. Then measurement of directivity. In measurement of directivity, directivity is 5 max by 5 AV. 5 max by 5 AV is WR by 4 pi. 4 pi times of 5 max by WR. Directivity is 4 pi times of 5 max. WR is double integral of phi of d omega. D omega is elementary solid angle, which is sin theta, d theta, d phi. Because double integral is involved here now, we use graphical numerical methods. We use graphical numerical methods. In these graphical numerical methods, what we use is orange slice method, where angle phi is kept constant, and conical cut method, where angle theta is kept constant. So this we have discussed under antennas dia. The second half, we also went for wave propagation. All this in detail we have discussed in antennas Maha Marathon series dia. Please go through them. In wave propagation, it's in principal modes of propagation. Principal modes of propagation. Under principal modes of propagation, it's in ground wave propagation, sky wave propagation, and space wave propagation. Ground wave propagation is up to 2 megahertz. Sky wave has been 2 megahertz to 30 megahertz. Space wave is in between 30 megahertz to 300 megahertz. The major application here is the AM radio. Here the major application is the FM radio. Other than that, we are also seen some special modes of propagation. Special modes of propagation. In special modes of propagation, we had seen scatter propagation. Under scatter propagation, we had seen tropospheric scatter, and ionospheric scatter. Tropospheric scatter allowing frequencies between 100 megahertz to 10 gigahertz, and ionospheric scatter allowing frequencies between 25 megahertz to 60 megahertz. Then we had seen ductal propagation. The propagation happens through super refraction and allows frequencies between 300 megahertz to 30 gigahertz. Formation of Inversion layers is the main reason for the formation for duct propagation. And also we had seen okay, structure of atmosphere. In structure of atmosphere we have seen structure of troposphere, mainly we had seen structure of ionosphere in depth. All those layers, stratification process, everything, ionic densities and all were discussed in detail in structure of ionosphere. Please go to the Antennas Mahamarathon series for a detailed explanation of this. We have derived refractive index of ionosphere, mu or n, which is sin I by sin r under root of 1 minus 81 n by f square. And we have seen mechanism of radio waves bending by ionosphere, critical frequency, maximum usable frequency, least usable frequency, optimum working frequency, and skip distance. And also we had gone through ionospheric abnormalities, where we had discussed about 10 different functions here, 10 different situations here. Please go through Antennas Mahamarathon series for a detailed explanation of these. We had seen ionospheric abnormalities, in which mainly we have discussed about sudden ionospheric disturbances, or also called as Mongol-Delinger effect. And we have seen ionospheric storms, sunspot cycle. These are three major ones, and other small things are there, like fading, man-made noise and all. Some 10 points were discussed under this ionospheric abnormalities, and we derived the derivation for range of space wave propagation, and we have seen the value of received electric field strength in space wave propagation. We have derived the formula. We got 88 root p HT HR by lambda d square volt per meter. And also we had seen terms like fading and path loss calculation. Please go through how much you got. Path loss calculation 32.45, 20 log distance in kilometer, 20 log frequency in megahertz. So this we had seen, all this we had seen in Antennas Mahamarathon series. It's covered 18 videos and 38 hours. Okay? We're into the MCQs. Now just find out which mode is odd one out. Normal mode, axial mode, endifier mode, beam mode. Axial means in a helical antenna we find axial mode when circumference is approximately equal to lambda. The antenna will fire along the axis in axial mode. So it fires at the end of the array. Yes, it's also called beam mode. These three are same. So odd one out is normal mode. Option A is the answer. Which mode is odd one out here? Normal mode means the antenna size is very small. The helical antenna size is very small, such that n into L is far less than lambda. L is length on each turn, n is number of turns, n into L is far less than lambda. Clear? It's a small antenna, radiation will be perpendicular to the axis. Perpendicular, broadside or normal, all are same. So odd one out is axial. Option B is the answer. The axial length of helix is given by, if you take an helix, what is the axial length? This is the axial length A. How much it is? These are turns, n, number of turns. How many are there? 1, 2, 3. 3 are there. Spacing. This is spacing. Yes. If you do multiply with this number of turns into spacing, you get the axial length. N into S. N into S. Option B is the answer. Which mode has narrow bandwidth? Narrow bandwidth, very sensitive, is normal mode. It has narrow bandwidth. Can't be used for large bandwidth applications. Option A is the answer. Which mode has less efficiency? Normal mode has less efficiency, generally used in Wi-Fi router. Wi-Fi router. Radiation pattern of which antenna is a combination of short dipole and small loop? See, this is short dipole, small loop. Again, short dipole and loop. Short dipole and loop. Short dipole loop combination is nothing but a helical antenna. Radiation pattern of which antenna is equal to the combination of short dipole and small loop, helical antenna. Option D is the answer. For loop antenna winding of helical antenna, pitch angle is, see, this is the helical antenna. Loop antenna means like this, and this is circumference, this is length on each turn, and this is spacing, and this is pitch angle alpha. Now if you want to make this loop, slowly this alpha is getting suppressed. So for loop antenna, how much alpha you get? Alpha is 0. For a loop antenna, winding of helical antenna, pitch angle alpha is 0. For short dipole winding of helical, pitch angle is, for short dipole winding, see here, this length on each turn, the circumference, the spacing between them. Now for short dipole, we are trying to make it straight. We're trying to make it straight like this. Angle will be this, 90 degrees. So for loop antenna, alpha is 0. For dipole, alpha is 90. That's the conclusion. In helical antenna, its spacing is made 0. This helical antenna. This is spacing. If spacing is made 0, what happens? All these rings will fall one on the other. What you can see is only one ring. That is, you will form a loop antenna. Option A is the answer. In helical antenna, If S is constant, the spacing is constant, and D is tending to 0, it results in dash antenna. If spacing is constant, this spacing is constant, but this diameter is tending to 0. That means what? You will get this short dipole. It results in short dipole antenna. Option B is the answer. The far field pattern of small loop and short dipole are out of phase by, they are always out of phase by 90. If you can see the expression, you'll get the understanding. The formula for pitch angle in terms of circumference and wavelength. Circumference C and wavelength lambda. Pitch angle alpha is equal to tan inverse of C by 2 lambda. We have done the derivation helical antenna. Please refer the antennas Mahamarathon series. Very important question for MCQ. C value, sometimes C value and lambda value will be given or frequency will be given. We will ask you to find alpha value. Axial mode. In axial mode, diameter of the helix is approximately. In axial mode, circumference is approximately equal to lambda. Circumference is pi d is approximately equal to lambda. Diameter is lambda by pi. So diameter is approximately equal to lambda by 3. Option B is the answer. Helical antenna is operated in axial mode with 100 turns. Axial ratio is given by 1 plus 1 by 2n formula. Very important question, dear. Very important question. So, axial ratio is 1 plus 1 by 2n. 200. 1 plus 0.005. 1.005 is the axial ratio. Option C is the answer. Option C is the answer. It indicates that if the number of turns increases, the axial ratio will go very close to 1, which can produce circular polarization. In axial mode, circumference of the helix is generally in the range of 3 by 4 lambda to 4 by 3 lambda. Generally they say circumference must be approximately equal to lambda. Range is 3 by 4 lambda to 4 by 3 lambda. Very important question again. Option C is the answer. Helical antenna is a dash antenna in normal mode. You know that when it is operating in a normal mode, it acts like a resonant antenna. We had expressed this in the theory. We discussed this in the theory. Option A is the answer. Okay. Rest of these questions we'll try to discuss in the next class. Unacademy offers 2 paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly tests, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, you'll have all these features. Along with that, you have a personal coach for one-on-one guidance, dedicated doubt-clearing educators to clear your doubts, preparatory study material, personalized test analysis, study booster sessions and study planner. If you're going Plus subscription or Iconic subscription, I recommend you to go for a no-cost EMI where total cost will be divided by number of months. You can use our team code KNR10, which not only gives you 10% off, but also gives you complete team support. With Iconic subscription, you will get 1:1 live mentoring, increasing your chance of getting a top rank. The good news for GATE and ESC aspirants is that the notes are now available, which are curated by India's topmost educator, and you can find material for quick reference, accessible anywhere and anytime, and it is available for both Plus and Iconic learners. To subscribe, you can use the team code KNR10. These are the results. These results will show the strength of Unacademy. We have India's topmost educators. That is the reason why you get this kind of results, and results are very evident that Unacademy is best for you people to start your preparation. We have GATE 2022 Rankers Summit, which is live on YouTube today at 6:30 p.m. dear. Try to attend live. There is a price rise from April 1st. So make a note. Try to subscribe soon by using the code KNR10. Today we got this GATE and ESC combat, March 27, 11 a.m. 20 questions, 60 minutes, separate paper for mechanical, civil, electrical, EC and CSIT. Those who score rank 1 to 3, 100% scholarship will give, 4 to 10, 75%, 11 to 50, 50%, and 51 to 100 we have 25% scholarship. If you are having any doubts, you can contact our counselor. If you have any doubts in preparation journey, subscription or latest offers, you can contact our counselor dear. This Unacademy Ask a Doubt feature through which you can ask unlimited number of doubts. You can ask 3 doubts at a time, get the solution in your preferred language. And also it is very easy to ask your doubt, just click crop and submit. These are special class features where you have interactive live classes, polls for the learners, raise hand option, you never miss a class when the notification is on. With the lecture notes, we can download the lecture notes, you can access anytime and anywhere. We are introducing community where you never miss any update from your favorite educator, and you can get the session notes and practice material and share the feedback directly with the educator via polls. This target GATE and ESC 2023 for EC explained bilingual started on March 23rd. This Vision GATE and ESC 2024 started March 23rd for EC explained bilingual. Target GATE and ESC 2023 for electrical explained bilingual. Vision GATE and ESC 2024 for electrical explained bilingual started March 23rd. Resilience batch for GATE 2023 will start on March 30 for electrical explained bilingual. Resilience batch for GATE 2023 for EC explained bilingual will start on March 30th. Thank you all for joining and have a great day dear.